Hello, and welcome back to Introduction to Data Science with R for Social Scientists. In this session, I want to talk about joining data, or otherwise called relational data. Now, so far, we've only talked about one specific case, namely that all our data, all the relevant data for our analysis, is present in one data frame. Let's call it X here. However, out in the wild, this is not always the case. There are several reasons why your data might be split between several data frames. So, for example, maybe you found another data frame which has additional variables that would be interesting in your present analysis, and you found that there's a common overlap which you can use to join these data frames. Or sometimes one and the same dataset was split into several tables to make it easier to store them. We've seen something similar in the last session where we had table 4a and 4b, which really belonged to the same dataset but were split in that case for unknown reasons. However, imagine you have, for example, a dataset where you keep all speeches of politicians in the German parliament. This is X, and then it also contains all of the demographics of the different parliamentarians, the age, their election district, their party, and so on. Since one politician makes multiple speeches per year, probably dozens or even hundreds, the demographics data is duplicated again and again, which makes these datasets rather large. So we want to split this up and keep only the demographics in one data frame, and then we have the speeches in another frame. And whenever we want to answer a question about dataset X that includes demographics, for example, do the speeches of male politicians last longer or get interrupted less often, then we need the gender of the parliamentarian back, and we have to reattach data frame Y to data frame X to get the complete picture. So how can we imagine this in practice? I prepared here the data frame table 4a and table 4b in a spreadsheet, and we've tidied them already last time. So what we could do to make these whole again is to simply reattach the data frames together. Now, what you can see is that we now have a bit of duplication. We have the variable country twice and we have the variable year twice. Also, in this case, you can imagine a Venn diagram where the circles for X and Y perfectly overlap. And so all you need to do to join these two data frames is to simply attach one of them to the right of the other. However, this is usually not the case. So let's imagine a more realistic case where one of the variables has a completely different order. So now when you want to join the dataset, you can't simply attach them to each other. You need to somehow attach the actual observations to the other table. And we can do this using keys. Now, this chapter in the book particular was full of vocabulary that might be useful if you get really, really deep into relational data, but in our case, you can probably forget most of the new terms that you've learned. It's easier to just once understand the functions that we learn in this session, and then you can apply them to all kinds of different situations. However, one vocabulary that I found quite useful was key, and here we can refer to a primary key and a foreign key. Now, let's look at table 4a on the left here, and what we could choose as the primary key would be the country, but as you can see, we have some duplication in the country. So right away, if we want to attach the additional variables, we could choose Afghanistan and Afghanistan here, but then we would have to attach both Afghanistan cases. So once we have a population of a little below 20 million, and once we have a population of a little bit over 20 million. So we would have to duplicate the first observation and also the second observation, and instead of 2 rows with Afghanistan, we would have 4 rows immediately. In this case, the primary key is rather a combination of variables. So the combination which uniquely identifies each observation. In this case, we have the country and year. So once we have Afghanistan and 1999, we can now create a new column and sort the values accordingly. So Afghanistan 1999 is still the first value. The second value is Afghanistan 2000, so we have to go a little further down and we take this value here. Then Brazil 1999 is over here. Brazil 2000 is up here. China 1999 is here, and China 2000 is the second one from the top. So now we joined these two data sets using a key, and you've already seen one of the good practices that is mentioned in the book, namely that the primary key really identifies the unique cases in your first data set. However, just because the primary key is unique does not necessarily mean it only has one equivalent in the foreign key. So the foreign key is the variable or variables in the second dataset that you want to join to the first that uniquely identifies cases there. And let's assume the data looks a little bit different. So let's say you don't have a year variable in your first data frame X over here. You only have the country, and the country uniquely identifies the different cases. But what do you do when you now want to join the population data to this data frame? Do you now join the first? Do you know add the population? Add the population of Afghanistan from the year 1999 or the year 2000? And what do you do with the country Germany, which has a representation in the first data frame, but not in the second over here? This is exactly why we have different dplyr verbs to join two data frames. They each do something different with the cases that are either only present in X or only present in Y. So let's get into it. Let's start with left join, which is by far the most common of the join verbs. Left join only cares about the observations that are present in X and only adds variables from Y where an observation has a relationship with one of the observations in X. We can also see this in the diagrams that the book provided. So let's say we have a variable x1 and a key that's called 1. We look for a representation for this in the Y data frame to add the variable that is only present in the Y data frame. We look for an observation where the foreign key is also 1, and then we join this data together. The same happens for the observation where our primary key is 2, and we also have an observation in our second table where we have a foreign key with a 2, and we can therefore add y2 to our data frame. For the primary key 3, however, there is no relationship with any observation in the Y data frame, so we have to add an NA here. Left join is also one of the mutating joins, which means that all variables from X and Y are kept and joined together. So you can see that the variable with the values x1, x2, and x3 is still present in the newly created joined data frame, and y1, y2 are still present in the new data frame as well. Since there's no relation with any observation 3 in the Y data frame, we have an NA in the new table. Next up, we have the right join. And this is very similar to the left join, but this time we disregard cases which are not present. But in this case, we disregard cases which are not present in X. So if you look again at the diagram down here, you can see that the fourth value is NA, that the fourth value is NA, since in the Y data frame there is a key with the number 4, but this is not present in the X data frame. So in the new table that we get, we have a row where val x, the variable that comes from our X data frame, is NA. The observation with the key 3, however, is completely missing from the new table. It is simply removed, as was the observation with the key 4 in the new table that was created using left join. Then we have the variable full join, and in this case we keep all observations from our X data frame and all observations from our Y data frame. And wherever there isn't a relation between observations in X and Y, we simply add an NA value. And finally, there is inner join, where we only keep observations that have a shared key between X and Y. So all other cases are simply disregarded, and we have a nice clean data frame with no NAs. So let's practice these 4 functions a bit. We are back in R here, and we start very easy with 2 data frames that contain the bare minimum we need for matching. We have one data frame with ID and values, and then we have df2 again with ID and values too. So what we want to do is we want to join these together, and by default what the functions do is to join data frame called Y to the right of the data frame called X. So let's try this out. Let's use left join. And as you can see in the help that opens, the arguments are called X and Y, just as in our diagram. So the X data frame here should be df1, and then the Y data frame should be df2. And now the only other thing that we need here is the key, which is called by. So since our foreign key and our primary key are both called ID here, we can simply use a character string with the value ID. And once we've done this, voila, we have a new data frame where df1 and df2 live together, and they now have 2 values variables, values and values 2. We can also do this with right join. And here the arguments are exactly the same. The difference that you see now is how the NA value in df1 is treated. So with left join, this observation is kept. It has a value, it does not have a key value, and necessarily the NA value does not have a representation in the other data frame. So while the observation is kept with left join, it is removed with right join. Let's make this a little bit more complicated with another example. So here we have 2 new data frames. They are again called df1 and df2, and I'm using the tribble function from the Tibble package this time, so you can see more clearly the data entry process of our 2 data frames. Let's run this, and then we can look again at them in the viewer. So in this data set, we have a column called animal, a column called name, and a column called breed. In this data set, we have some information about the pets of some people, and we know about these pets, what they are called, and what breed they are. And then in the second data frame here, we have a column called animal, one called breed, and one called life expectancy. So what we want to do is we want to add the life expectancy to the table with the specific animals. So let's go ahead and type in our left join command. The X data frame here is again df1, and the Y data frame is again df2. So then we have to select a key variable. What comes to mind is that we could select the animal variable. So let's do this and see what happens. Now, the first thing you notice is that we now have a breed X and a breed Y variable. And the reason for this is because the variable was duplicated in the newly created data frame. And as you already know, we can't have duplicated column names, so they get renamed. When we look at the help file here, you can see that we can control the new names with the suffix argument. So what we could do here is we could replace the points with underscores, simply because the new column names would look a little bit nicer. What you can also see here, though, is that we have duplication now in our new data set. So we have the cat called Leo in here twice, and we have the cat called Charlie in here twice. When we look again at df1, we immediately see what the problem is, namely that our key variable does not uniquely identify the observations. So animal is in here twice, once because of the cat named Leo and once because of the cat named Charlie. So what we need to do instead is to create a unique key, and I'm typing this into a new command. And to show you the syntax here, what we want is the C again, so the concatenate. And we create our own unique key by combining animal and breed. And here we go, we got rid of the duplication in the observations as well as in the variable names. Now, what you still notice here is that we have an NA value, even though there was no NA value in either one of the two data frames. And this is, of course, since the pet named Tina is a horse, and we don't have any information on horses in our df2. So what we could do to get rid of the NA value would be to use a right join if we wanted to have specific animals for our animal data. So for example, we wanted to test something about life expectancy from the data set. Of course, the variables aren't here, but let's imagine they were. And we only wanted to find complete cases of animals for the different species in our dataset. So we could use right join, and the other arguments are exactly the same. So again, we want to combine animal and breed to get a unique identifier. And this time the result looks very similar, except that we now have an NA value for snakes, since there is no snake in our df1. What you should know about the difference between left join and right join, however, is that you could accomplish to create the substantially same data frame with a left join by simply switching df1 with a df2. So now the name is over on the right, since we're joining df1 to df2, but substantially the same values are in this new data frame. Then let's try out the other two join functions that we learned. First, we want to try full join. And again, we can just copy the arguments. And when we do this now, we have both an NA value for a snake in the name variable and an NA value for Tina the horse in our life expectancy. And then lastly, we have the inner join. And here we completely got rid of all NA values, since only complete observations where there is a relationship between animal breed in df1 and animal breed in df2 are present in this new data frame. And now to kick this up a final notch, let's add another example. Now the difference here is that the key variables in df1 are called animal and breed, and the key variables in df2 are called animal and species. So how do you express this in the syntax of the join function? Let's take join left, and then once it comes to defining what the key variables should be, we start as the last time with animal. And then we have to create a named vector similar to how we do this in creating a tibble. But just to make this clearer, we wrap the quotation marks around both the name of this and the actual value. So in other words, the syntax reads that df1 and df2 should be joined by animal, and then we look for a relationship between breed in df1 and species in df2. And if we run this now, we get the same data frame as before. And now that we have the first 4 functions covered and we know what they do in R, we can hop to the remaining 2. So the next one is called semi-join, and on first glance it looks like it is doing exactly the same as inner join. It basically only cares about this area where we have an observation in X which has a relationship to an observation in Y. However, we now started with the filtering joins, and semi-join only keeps variables from X. So when you focus on this table at the bottom here and compare it with inner join, we see that we have here one variable called val_x and one called val_y. The first one is from our X data frame, the second one is from our Y data frame. And when we compare this with the result from the semi-join function, we see that it now only kept the variable from our X data frame. And finally, we have anti-join. And anti-join does the exact opposite from semi-join. It only keeps the cases from X that have no relationship with any of the cases in Y. So to test out the last 2 functions, I simply use the same data frames here. And let's try semi-join. I simply copy over the last left join that we used and replace the left with semi. And when I run this now, I only get the observations from df1, which have a relationship to one of the observations in df2. And we can do the same for anti-join. Here the only observation we keep is the horse Tina, because we had no data in df2 about horses. So why are these functions useful? I can show this by doing the same operations in a way that we already tried, which is we could use filter for the same task. And in filter, what we could do is we could say that we only want to keep observations where the animal is in the names of the animals in df2. And then the breed is in an observation which has the species here. And as we've learned in the session where I introduced filters, you actually need to use the in operator for this. So here we go. We have 4 rows. Leo, Bruno, Charlie, and Caesar are still in here. And this is exactly the same as if we've done this with semi-join. And then we can accomplish the same thing for anti-join. Here all we need to do is add the exclamation mark to our 2 filter conditions. So as you can see, this code is somewhat more complex than our semi-join and anti-join. And as you can imagine, it quickly gets more and more complex once you add more variables. Often we don't have just 1 or 2 key variables. We have many more. And so this becomes rather cumbersome to write. But of course, feel free to use filter wherever the filtering join functions seem too complicated. And now that we have some practice, let's focus on a little case study. As in the book, I'm looking at the flights data set, and what we could do here is to simply create one complete data frame with all of the different individual tables that are present in this data set. So let's see how this would work. We first load the package with the New York City flights data. And we start with flights because this is the one that is apparently central to this collection of data frames that is in the New York flights data. But you could also start from anywhere else in this diagram, and you could still make your way through the entire thing and add the different data frames together. So we start with flights, and to this we want to left join the planes. So let's go with planes, and as you can see here, the key variable is tail num for the tail number of the plane. So what we want to do is to use by and then tail num, and this should work. Let's have a look at it with the viewer. And as you can see here, we apparently had some duplication between the 2 data frames. We now have a new column called year X. And yeah, we have a representation for this over here in year Y. However, notice that here our year Y value for the first observation is 1999. And then the year X variable is 2013. So what's happening here is that 2013 is the year of the flight, and then 1999 is the year when the airplane was built. So what we could do is to add an informative suffix to this. And I think in this case it makes sense to simply leave the suffix for X empty. And for Y we can add the suffix built, just because it's a little shorter than manufactured or whatever else you could call this. So let's look again at the new data frame, and let's also see if the suffix was added to anything else. But this does not seem to be the case. So now we have year built, and we have year, which indicates when flight started. I can also see that we have several NA observations here, so I assume that not all of the tail numbers were represented in the airplane's data frame. So then let's add the next data frame to our collection, and this is the airport's data frame. So let's again left join, and as you can see already, left join is by far the most useful of these join functions, because this is what you usually want to do. You don't want to silently get rid of observations in your initial data set. You simply want to add variables wherever they are present anywhere else. And here the connection is a little bit, and here the key variable is a little bit more complicated. So airports connects to origin as well as destination. So what we need to do is, again, to first have the key in our flights data, and we could choose origin or destination. I'm choosing origin here, and then we have the equal sign and FAA, which is the foreign key in airports. And there we go. This looks pretty good. We have a time zone now. We have latitude and longitude. We have the name of the airport. So this is all looking pretty fine. Let's build this up further. Let's go with the weather. And here we have several keys that we need to combine. So again, we use concatenate for this, and then we want year. So it's a good thing we didn't use the year of the plane manufacturing, because this wouldn't have any representations here, and we just kept the name of year in the flights data set. Then we want month, day, hour, and origin. And when we do this now, we see that we have wind speed, we have humidity, we have the temperature, pressure, and so on. Time hour apparently is now duplicated, but I don't think this is especially important. We could remove it though, but I think we are good. And then for airlines, I'll leave this up to you, because I think you get the point now. This was a really easy case study this time, but I think in the end, the join functions are relatively simple once you wrap your head around the theory that underlies them, and you understand how powerful it can be to combine different data sets. If you want to combine several different data sets for your project, I think this would be an excellent idea, especially if you want to write a seminar paper, because this is where you would usually find the most interesting results and where you can tell the most interesting stories about data. And with that, I'm leaving you for today. I'm copying the exercises from the book again in here. I think we've already covered some of them, but I'm happy to look over them once you're done with this homework, and I hope to see you next time.